In this video, we'll continue to look at coordinate geometry, and we look at this question. Now this question says, the line joining the points A minus 1, 3 and B 5, 15 meet the axes at P and Q. Find the equation of AB and calculate the length of PQ. So we've gone ahead and we tried to represent the situation on a pair of axes, X and Y axes. So basically have our y-axis and our x-axis. So we let this point over here be A, which is minus 1, 3. So if this is a point minus 1, 3, then B, which has coordinates 5, 15, would be somewhere over here, right? And of course, we managed to go ahead and draw the line joining these 2 points A and B. And of course, it cuts the y-axis at the point Q, and it cuts the x-axis at the point P. So they basically want us to find the equation of AB, and then of course go ahead and calculate the length of PQ, which of course means that we'll have to find the coordinates of P and Q. So let's go ahead and do that. So we'll write down the coordinates of the points A and B. So we have A, which is minus 1, 3, and we have B, which is 5, 15. So let's of course call this point x1, y1, and this point x2, y2. So in order to find the equation of AB, we first have to find the gradient of AB, and then having found the gradient of AB, we'll use that together with one of the points, either A or B, to find the equation of AB. So let's find the gradient of AB. So the gradient of AB is equal to y2 minus y1 divided by x2 minus x1. So this gives us 15 minus 3 divided by 5 minus 1. So this gives us 12 divided by these two minus signs multiplied to become a plus. So 5 plus 1, that gives us 6. And so the gradient of AB is equal to 2, right? So having found the gradient of AB, let's now use, so using the point A, which is minus 1, 3, and the gradient, which is 2, we can now say that y minus y1 is equal to m brackets x minus x1, where in this particular case, x1, y1, of course, is a point A with coordinates minus 1, 3. So we get that y minus 3 is equal to the gradient 2 times x minus 1. And so we get that y minus 3 is equal to 2 times x plus 1. And so we have y minus 3 is equal to 2x plus 2. And from that, we can bring the 3 across. So let's just bring the 3 across, right? So we get that y would be equal to 2x plus 2 plus 3. And so we get that y is equal to 2x plus 5, right? So this, of course, will be the equation of AB. The equation of AB is y equals 2x plus 5. Now, if you look back at our diagram, we will see that the line AB cuts the y-axis at Q, and it cuts the x-axis at P. So let's find the coordinate of P and Q. Now, at P, the y-axis of the y value, of course, will be equal to 0. So when any line or curve cuts the x-axis or touches the x-axis, at that point, the y-coordinate is equal to 0. And similarly, wherever the line touches or cuts the y-axis, the x-coordinate there will be equal to 0. So we'll make those substitutions and then find the corresponding value of x and y respectively. So for the point P, so we could say that at P, y equals 0. And so we see that 2x plus 5 equals 0, 2x equals minus 5, and therefore x equals minus 5 over 2, which therefore means that P is the point minus 5 over 2, 0. So those are the coordinates of the point P. Now let's do the same thing, or the similar thing for Q. So say at Q, the Q, which of course cuts the x-axis. So at Q, x is equal to 0. So we'll substitute x equals 0, and of course we'll solve for y. So this gives us y is equal to 0 plus 5, and so y is equal to 5. And therefore this means that Q is the point 0, 5. So we've managed to find the coordinate of P and the coordinates of Q, and now what they really want us to find is the length of the line PQ. So let's now go ahead and find the length of PQ. So let's make some space. Where do I do it? All right, let's just do it here. So I want to find the length of PQ. Now, if you recall, the length of any line, PQ is equal to root x1 minus x2 squared plus y1 minus y2 squared. In this particular case, each of those points has only one non-zero coordinate. So P, for instance, has non-zero coordinate minus 5 or 2, and Q has non-zero coordinate 5. So we can say that this is going to be equal to the length of PQ. All right, let me just erase. Yeah, since I'm no longer in need of the diagram, I will just erase this. No, let me just continue. So find the length of PQ. Length of PQ is equal to root x1 minus x2 all squared plus y1 minus y2 all squared. So this is equal to root basically of 0 minus 5 over 2 squared plus 5 minus 0 all squared, right? So the same thing as root 5 over 2 squared plus 5 squared. And so this gives us this gives us 25 over 4 plus 25, and this is going to be equal to, this is the same thing as 100 over 4, root of 125 over 4. So the length of PQ the exact length of PQ will be equal to root of 125 over 4. But if you want to express that as a non-surd, we could basically say that 125 divided by 4, that's so that gives us approximately 5.6 units. So approximately 5.6 units correct to two significant figures. All right. So there we're able to find the equation of AB, and of course from that we're able to find the coordinates of the points P and Q, and hence we're able to find the length of the line PQ.